And we are live. Welcome to Math with Doug. This week it is Geometry with Doug. And we are going to be looking at some rectangles and some other shapes. This is Mocha. Her job is to sit over there and not disturb us. I'm going to put her down. Okay, lie down. Stay. It's cold outside. I don't want to talk about it. This is a Liverpool shirt. I'd love to talk about that for hours, but I won't. And let's get into the math. Okay, so I have drawn three rectangles here. What is a rectangle? A rectangle is a quadrilateral, which means it is a four-sided shape. It has two pairs of parallel congruent sides and four internal 90-degree angles. So what does that mean? Okay, so this side down here is parallel to this one. This side over there is parallel to that one. We will refer to the side that I have drawn horizontally here as the base, and this side that is perpendicular to it as the height. I have marked with the little squares the four internal 90-degree angles, otherwise known as right angles or square angles. And with quadrilaterals, the four internal angles total 360 degrees. So when we know all four of these are 90 degrees, 4 times 90 is equal to 360, that makes sense. Now, let's get into perimeter. So what is perimeter? Perimeter is the distance around the outside edge of the shape. So, what you might realize is, since we know that the opposite sides are congruent, meaning equal in length to each other, that means I don't have to label all four of the sides in my rectangle. If this one is 18 inches, it means this one over there is 18 inches. If this is 14 inches, then that is 14 inches. So the base of this rectangle is 18 inches and the height is 14 inches. And that's what the B and the H stand for in this little perimeter formula I have thrown together. One of the ways of finding the perimeter is to simply add together the length of all four sides. So I'll do that. In this example, let's make sure that we can see that. Okay, so the base is 18 inches. To that I add the height, which is 14 inches. But now I have to add the base, which is this 18 inches. So what I'm doing here is I am going around the outside edge of the rectangle, and I'm just adding together all four of the lengths that I have. So I have plus 18, and then finally this height over here is another plus 14. 18 plus 14 plus 18 plus 14, 10, 20, 30, 40, 48, 56, it's 64. So the perimeter of this rectangle is 64 inches. Fairly simple thing to do, and that works with all sorts of shapes that you can just add together the lengths of all the sides. So here I'm doing something very similar. I've sort of created the formula to look a little different though. Here, with this middle rectangle, I'm going to use this version of the same formula, but it's base plus height plus height. So I'm just dealing with the two bases first, and then I'm doing the two heights last. So the base of this rectangle is 20 inches. And then, of course, the side opposite is also 20 inches. The height is 17, and the side opposite that height is also 17. And now we add them together and we get our perimeter. 20, 40, 50, 60, 67, 74. 74 inches is the perimeter. The way I've arranged the two bases together and the two heights together sort of leads us to doing this version of the perimeter formula, which I'll use for the last of these three rectangles. It means that we take the base and multiply it by 2, and then we add that to the height, which has also been multiplied by 2. Which means, of course, we're really doing the exact same thing we did here and here. So don't be alarmed if you see different versions of this perimeter formula. So long as you're able to get the perimeter correctly, it doesn't matter which version of the formula you use. Let's do this one. The base is 24 inches, so I'm doing 2 times 24, plus the height is 10 inches, 2 times 10. And simplifying, 2 times 24 is equal to 48, and 2 times 10 is equal to 20. So the overall perimeter of this last rectangle is 68 inches. I have my perimeter. So no matter how you like to put together the formula, no matter how you like to do the calculation, if you can get the total length around the outside edge of the object, then you have the perimeter and you are doing it right. That's pretty good. Okay, but I'm going to erase the perimeter calculations now because I also want to show how we find the area of the rectangle. Okay, erase, erase, and erase. Now the area of a rectangle is a fairly straightforward formula, which you probably have already seen, and which people tend to memorize early on in their geometry career and then never forget, because it is quite simple. So the area is equal to the base times the height, which is going to be, in this case, 18 times 14. Okay, 18 times 14, do I dare do this in my head? 10 times 18 is 180, 4 times 18 will be 72, 180 plus 72, that would be 252. And it is square inches. It's area, so the unit is squared. So I'll write IN for inches so that I can attach this little 2 and show that I have square inches. And then because Doug has learned his lesson, I'm going to multiply on my calculator and make sure I did not make a mistake. 18 times 14, 252, I got it. Okay, this one, all these last two, I have a feeling I can do these calculations in my head without making a mistake. The area, and I'm not showing all sorts of different versions of the area formula, do I have to? Well, I have seen area equals length times width, which really means the same thing as area equals base times height. So if you see, again, if you see a different looking version of the formula, don't panic. You are multiplying the base times the height, whether you call them that or not, to get the area. So the length of this one is 20, and we're multiplying it by the height, which is 17. And yes, I think I can do this in my head without making a mistake, because 10 times 17 is 170, so 20 times 17 will be 2 times 170. That will be 340 square inches. Got it. Going back to my original version of the formula, area equals base times height. Let's do this last one, another kind of easy one, don't you think? The base is 24, we're multiplying it by the height, which is 10. Multiplying by 10 is fairly easy. 24 times 10 will be 240. We have 240 square inches. So the area of a rectangle formula is easy to use, it's easy to remember, and that's good because it's very useful to help us understand the area formulas for some of the other shapes that we want to cover in this lesson. Let's see now, is there anything else on my list of stuff to cover? I think I'm just going to do one more rectangle. I'm going to make up a rectangle that would be, for instance, a backyard that I might have to mow. So let's say we have a rectangular backyard and it's all grass and we have to mow it. We want to know how much area we have to mow. This is a practical application of the way we use our rectangle geometry and our area formula. So let's do that. Let's think about that backyard that's shaped like a rectangle. What I'll do is I'll keep this figure, but I'll relabel the measurements of the sides. So we'll say that's our backyard. And I'll erase everything else that I have here. Except the word rectangle, because I'm not finished with rectangles, not just yet. Okay, let's say that, let me think of a sort of a normal sounding dimensions for a backyard. In feet. What if the base of the rectangle were to be 50 feet and the height of the rectangle were to be 40 feet? Okay, so let's apply what we've been learning, but in a real life situation. If I want to know what area of grass I have to mow, the area is equal to the base times the height of the rectangle, which is going to be 50 times 40, which should be 2,000. Oh, it's a nice big number. 2,000 square feet. Okay, double checking my answer, but feeling quite confident. Yes, 2,000 square feet. Seems like an awfully big answer, but that sort of thing happens when we multiply. So I have to mow 2,000 square feet of grass in this yard. That's not so bad. It wouldn't take so long. It's not a very big yard. What if I want to know the perimeter? Why would I want to know the perimeter? What if I wanted to build a fence all the way around? Let's say there was no house built yet, and I wanted to put a fence all the way around just the backyard of this property. Well, I would need to know the perimeter of the property in order to know how long the fence is going to be and figure out how much wood I have to buy, etc. So the perimeter, let's use this version of the formula. 2 times the base plus 2 times the height. It's going to be 2 times 50 plus 2 times 40. 2 times 50 is 100, and 2 times 40 is 80. So I have 180 feet of fence that I have to build. Not such a big answer, but of course here we're multiplying and here we're adding. Okay, although yes, there are kind of little multiplications involved. All right, so we have seen it's almost like a word problem for the area and perimeter of a rectangle in a backyard situation. Okay, I'm going to move on to my next shape. I'm going to move on to the parallelogram. And what I've decided to do is I have some parallelograms that I decided to use. I'm going to draw them according to these specifications. If I had some students here, I would ask the students to name lengths and, well, bases and heights for parallelograms, and I would use their suggestions. But right now this is just a video, so what I'm going to do is I'm going to erase everything here, including the word rectangle, because we are moving on to the parallelogram. Okay, make sure this will show. Parallelogram is a nice long word. Wait, where's the double L? Parallel. Can't remember. I'm going to have to look up the word parallelogram so that I don't misspell it. And how many years have I been a math teacher? But it's one of those words that just gets me. I had it right the first time. I should have just gone with my instincts. Okay. So the first, we have the double L's, parallel, and then we have the single L, parallelogram. Whew. Why does geometry have such big words, long words? Parallelogram. Okay, I'm good. All right, so what is a parallelogram? It's not that different from a rectangle. Let's talk about it while drawing some. So my first one is going to have a 22-inch base. Put it way over here so that I can fit all three. There's a 22-inch base. The second one is going to have a 14-inch base, but it'll be taller, so I'll draw the base a little lower. 14. And the third one is going to have a 17-inch base. Okay, so much for that chalk. Starting over. 17. There it is, 17-inch base. Okay, that's a good start. Did I break the chalk in this thing? No. Okay. So let's do some heights. Now, with parallelogram, we don't have the, we were not going to draw just 90-degree angles. So we're going to have other angles besides 90. I'm going to let the height sort of dictate to me what angle I draw the parallelogram. And that means that I don't actually necessarily know the length of the short side. Let's see, what does he mean? Okay, so for the first one with the 22-inch base, I'm going to put an 8-inch height. Now I can draw this pretty much anywhere, and that will affect the angle I end up with the shape, but I'm choosing to draw it here. And I'm going to draw the height with a dotted line, and I'm going to mark the angle. So you can see that that's a 90-degree angle because the height has to be perpendicular to the base. It's in the definition of a height. So let's connect the top of that height to this end of my original line. And then by eye, I'm judging parallelism by eye, so I'm sort of freehanding here. I am holding the edge of the ruler so that's parallel to that base that I drew, and I want another base that's the same length, which was 22 inches. So 22 inches brings me all the way over here. I have to be careful I don't cross into the territory of the next parallelogram. Now, if I draw this side, that side is parallel to this one. This side is parallel to that one, and I guess that gives us a hint as to the name, why it's called a parallelogram. So the opposite sides are parallel and they're congruent, like with a rectangle. But the angles inside do not have to be 90. So we use the height in the formula for the area of the parallelogram. The area is going to be, will it fit here? I'll write it here. I'll just write here. Area is equal to base times height. Look a little familiar because it looks the same as the rectangle formula. The only thing is you have to be careful because with the rectangle you would choose the base and then you would take one of these other sides that are coming up off the base and you would say, well, that's giving me the height, and you would be correct. But in the case of the parallelogram, this line, this side is not perpendicular to the base, so it's not a height. The dotted line I drew is a height. So that's 8 inches, and the base is 22 inches. I don't even know how long this short side is, and I don't actually have to know it unless I decide to find the perimeter of this parallelogram. This is fun. Let's draw the other two. Let's finish the other two. So this one I want to have a 16-inch height. That's quite big. 16. Did I overdo it? No, it's going to look kind of good. So it's going to be quite a different angle than I ended up with that one. Drawing a 16-inch height. Again, I want to use a dotted line for this. I'll put the little square symbol that shows it's a right angle. And then I'm connecting the top of that dotted line to here. And I want another, this was 14 inches, I may as well mark that, 14 inches. And the height was 16 inches. I want another side that is parallel to this one that is also going to be 14 inches long. 14, there. And now when I connect these last two endpoints, I have my parallelogram. Not bad, a little bit freehand, I admit it. It may not be perfect, but it's quite good. Okay, now this one. This was a 17-inch base. And I decided to have a 15-inch height with it. Let's see here, 15 inches. I'll make the angle a little more steep. There, that's 15 inches. I'll connect these. Now, do I have to connect the top of the height right to one of the vertices of the shape? No. I could have drawn this dotted line in the middle here. But the way I'm doing it just makes it easier for me to draw it and have it turn out looking like a nice parallelogram. So that's my strategy. Okay, let's complete that side. And then this was a 17-inch base, so I need another 17 inches. This is going to go right off the rectangle of the video. We'll see, 17, a little higher. How's that looking? I think it's making it into the video, just barely. Okay, good. I have 3 parallelograms. All of them have their base and their height marked. For all 3 of them, we don't know the length of the short sides. But we don't need to know it in order to be able to calculate their areas. So let's calculate all 3 areas. I'm taking a look at the time, seeing how I'm doing for time. Area equals base times height, which in this case is 22 times 8. Do I dare do that in my head? 8 times 20 is 160. 8 times 2 is 60. 176 inches squared. Its area, the unit is squared. area equals base times height. Notice I am only using one version of the formula for this shape for the area, which is going to be 14 times 16. Now, 14 times 16, 10 times 16 is 160, 4 times 16 is 64, so 224 square inches. Oh, that's a mess. There. Okay, now this one. Area equals base times height, which is equal to 17 times 15, which is equal to 10 times 17 is 170, and 5 times 17 is 85. 170 plus 85, 255 square inches. And then I double check because I've learned my lesson. 17 times 15, yes. 14 times 16, yes. And 22 times 8. All of them are correct. Okay, so we've done all of the areas. Now, what about the perimeter? You can still find the perimeter of a parallelogram. Do we need to know the measure of this angle? Well, no, not for anything we're doing right now, but there are some situations where you would want to know the measurement of that angle. We're just not covering those today. Okay, so the perimeter is going to be the total of the four sides, and we can't use that formula with 2 times the base plus 2 times the height, because in the parallelogram, the height is not part of the perimeter. Perimeter means around the outside edge. This dotted line isn't around the outside edge. It's cutting through the inside of the shape. So I need to know the length of the short sides. All I can do to find that is measure. So these measurements are going to be slightly an estimate because I didn't necessarily draw it perfectly in the first place when I drew the base and the height. So when I measure this, any error I made before will come into my measurement, but it's going to be pretty close. I was kind of fussy when I drew these, and that's quite close to 10 inches. And this one is, I'll call that, what is that? I'll call that 16 and a half inches. That's kind of small the way I wrote that. And then this one, also 16 and a half inches. Interesting. Okay, so now we can figure out all three perimeters for all three of these parallelograms, but we can also think about what happened there. Since the height is 8 inches, and the height goes straight up, and this line tilts in order to reach that same point, it doesn't surprise me that this line is 10 inches. It's longer than that one. Same thing happened here. This is 16 inches, this is 16 and a half. It's not very much longer, but it's just a bit longer. Here, 15 inches, 16 and a half. It's always going to be longer. That makes sense. Why is this one so close? It has to do with the angle. Because this line is closest of the three left sides that I drew on these three parallelograms. This left side here is the closest to being perpendicular to the base. So that's a rather large angle. It might be 80 degrees or around there. So when you look at that and you think about it, it helps you to understand, and that helps you to feel confidence in the math that you're doing. Now, let's find the perimeter of all three of these shapes. I'll do this up here. And I'm just going to add the lengths of the four sides. I'm doing that. It's not base plus height plus base plus height because we're not using the height. So I'd have to say base plus short side plus base plus short side. I don't want to write all that. So what I'm going to do is I am just going to write perimeter equals, and it's going to be 22 plus 10 plus 22 plus 10, which is going to be 20, 40, 50, 60, 64 inches, not squared. It's a perimeter, it is not an area. This one, where will I do it? I'll do it down here. Perimeter equals 14 plus 16.5 plus 14 plus 16.5, which is going to be 61 inches. And then this one, I can do it up here again. Perimeter equals 17 plus 16.5 plus 17 plus 16.5, and that's going to give me what? 10, 20, 30, 40, 47, 54, 60, 67? 67 inches. Did that fit in the rectangle? Oh, just barely fit. Okay, that's good. This would have been more fun if I had students suggesting all of the lengths, all the bases and the heights, because then I wouldn't really know what I was going to get. And the cool thing about that is that the math still works. The area formula would still work. The perimeter formula would, perimeter calculation would still work. Everything still works, even if you're not even sure how big a parallelogram you're going to draw in the first place, even if you're not sure how long the bases will be, how long the heights will be, or how long the short sides will be. So we did a lot with these parallelograms, but we've pretty much run out of parallelogram time. So it's time for us to move on to the trapezoid. So you might have been thinking, oh, he's going to do a word problem involving mowing a lawn that's shaped like a parallelogram. No, not going to do that. I already did that once, it's enough. So moving on to our next shape, which is the trapezoid. And in fact, I want a little bit more time for the trapezoid because I want to cover more than one type of trapezoid. Because there is more than one type of trapezoid. So what's a trapezoid? Knowing what one is would kind of help. A trapezoid has a pair of parallel sides which do not have to be congruent. And it has another pair of sides which do not have to be parallel. I think that's a pretty good definition of a trapezoid. Then there's different types. Why would they be different types? Because that definition is a little bit more flexible, so there's actually more than one way of drawing a quadrilateral that obeys those rules. So I'm just going to talk about the two most common types of trapezoid, which are the right trapezoid and the isosceles trapezoid, and I'm going to start with the right trapezoid right now. So I'm going to start by drawing three bases. I'm drawing three right trapezoids. And the lengths I have chosen for those are 12 inches, 13 inches, and 15 inches. Let's get busy and do that. 12 inches. That's there, okay. 13 inches and 15 inches. There we go. Okay, and I'll label those right away. 12 inches, 13 inches, 15 inches. Okay, now the heights, they also have heights. Trapezoids have heights. So the heights of these three right trapezoids, which will be perpendicular to the bases because the height has to be perpendicular to the base. But these heights will actually be sides of the quadrilateral. So I'm going to draw them with solid lines, and I have heights of 10, 6, and 9 inches. So let's do a 10-inch here. And of course I am holding the edge of the ruler perpendicular to the base because this side has to be perpendicular. 10 inches, label it. And the other two were 6 and 9. 6 inches. So this is a small one, a bit of a shrimpy one. 6 inches and 9 inches. 9 inches. Okay, now I also need to draw the sides for each of them that are parallel and opposite to these bases that I drew. Let's see, I want to do this with a bit of variety. So for this one, we have a 12-inch first base. We're drawing this opposite side, which is also called the base. So we have base 1 and base 2. So base 1 is 12 inches. Base 2, I think I'm going to make that 8 inches, which is right there. This one, I am going to make it, we had 13 to start with, I'm going to make this base 2 10 inches long. And then this one, we started with 15, I'm going to do something different. I'm going to make the one opposite longer. So how about 18 inches in length? Will that fit in my video rectangle. 18 inches. I forgot to label these. This one was 10, yes. And this one was 8 inches, yes. Okay, did everything fit? Yes, everything fit. So I have to finish these trapezoids. They are quadrilaterals. They need 4 sides. So I need a 4th side, and I'm going to draw the 4th side just by simply connecting this end point with this end point. And you get to see what a right trapezoid looks like. Because these shapes are all different, but they all have some things in common. Now, if I were to draw this one upside down, so that the 13-inch base is on top, and the 10-inch base is on the bottom, it would still be a trapezoid. And it would still be a right trapezoid. So I can draw it that way if I want. I can twirl this shape any which way, and in fact all the shapes that we've dealt with so far in today's lesson, I can twirl them any which way that I want, and they still are that shape. The shape is independent of which direction it's facing, if you will. So, what else is, oh yes, because these are right trapezoids, I want to mark these angles. All of these are 90-degree angles. Now I put mine always on the left, but again, they don't have to be on the left. So I am marking the 90-degree angles, the right angles. A right trapezoid will have 2 right angles, and then it'll have 2 other angles that are not right. And I don't know what the measures of those angles are. I could find out if I wanted to measure them, but I don't need them right now. But I can tell you one thing, it's a quadrilateral, so if I knew what those 2 angles were, I know that I could add them together and then add this 90 and that 90 and get 360, because the rectangle and the parallelogram and the trapezoid all obey that rule that the 4 internal angles have to add up to 360 degrees because they are quadrilaterals. Okay, so I can find the area of all these. So I'm going to. Let's do it. How am I doing for time? I'm doing okay. I have to do okay because I want to also cover the isosceles trapezoid and the triangle. And there are different types of triangles as well. We'll see how much I can cover. Okay, the area formula for the trapezoid. Oh, and I never wrote the word trapezoid. Where will I put it? I'll put it here. There. Okay. The area formula is area equals 1/2 times, in brackets we put B1 plus B2, which means base 1 plus base 2. And it really doesn't matter which one you call base 1 and which one you call base 2, but they have to be opposite each other, they have to be parallel. Times the height. The height's involved too. So I'm doing that for all 3. Area equals 1/2 B1 plus B2, in brackets, times the height. Area equals 1/2 B1 plus B2, in brackets, times the height. So the first thing we have to do when we're simplifying this formula is we have to simplify the bracket. We have to follow the order of operations, which means we have to add together the length of the 2 bases. But let's fill in all of our information. 1/2. The bases here are 12 inches and 8 inches. 12 plus 8, and the height is 10. 1/2, 13 plus 10, and the height is 6. 1/2, 15 plus 18. Notice how the smaller one went first this time, and it doesn't matter. Times the height, which is 9. Why doesn't it matter? Because 15 plus 18 is the same thing as 18 plus 15. That's a rule about about addition that we're supposed to already know, and we should be very familiar with. Okay, 12 plus 8 is 20. So we have 1/2 times 20 times 10. I can put another bracket there if I want. I don't really know if I need it. Equals here, 13 plus 10 is 23. 1/2 times 23 times 6. And here 1/2, 15 plus 18 is 33 times 9. Didn't use the extra brackets in those ones. I don't need them. Okay, 1/2 of 20 is 10, and 10 times 10 equals 100. Wow, this one happens to have an area of 100 square inches. its area, so the unit is squared. Half of 23 would give me a decimal, so instead I'm going to do half of 6. Half of 6 is 3. 1/2 times 6 is 3. 3 times 23 will be 69. 69 inches squared. More chalk, please. And then this one, I didn't really leave much room, so I'll put it over here. Half of 33 would give a decimal, and half of 9 would also put a decimal, and that makes me want to grab at my calculator. 1/2 times 33 times 9, 148.5 square inches. Did that fit? Yes, it did. That's a good rectangle we've got going in this video right now. It's fitting a lot of examples quite well. Okay. Someone keeps staring at me because she's hungry. And in about 24 minutes, you will get your supper. Okay, let's see now. We have done the area. And it's a little bit of a weird looking formula. But like any formula, it's easy because you replace all of the letters with numbers and then you simplify. So formulas are not something to be afraid of. What about the perimeter? We're in a very similar situation to what we were in with the parallelogram, which is that we're almost ready to get the perimeter. We know 3 of the sides of this quadrilateral, but we don't know the 4th side. I would have to measure to get the 4th side. Now, measuring isn't always possible, but when you draw them the way I did, where I actually made this 13-inch side 13 inches, then we should be able to get, by measuring, a very good approximation of the length of this side, and then we can calculate our perimeter. Let's see. I'll do that. I guess I'll erase the areas, and then I'll just do all the perimeters. So, after all of that work, I erase all of my hard work, and let's find the perimeters of all 3 of these right trapezoids. And I need to measure to do it. And it's going to be very similar to what we did with the parallelogram. We're not applying some kind of formula, we're just adding together the lengths of all the sides. So the perimeter of this one is going to be 12 plus 10 plus 8 plus whatever this is, and I'm going to have to measure to get it. And that is giving me, I will call that 10.5, 10.5. So 12, 22, 30, 40.5, we have a 40.5 inch perimeter. Let's do this one. Perimeter equals 13 plus 6 plus 10 plus, what is this? It's going to be more than 6. Will it be 7? No, I would call that more of about 6.7. So 13 plus 6 is 19, plus 10 is 29, plus 6.7 is 35.7 inches. So these answers are approximate because of the fact that I am measuring and I drew. So the drawing I could introduce a little bit of error, and the measuring I could introduce a little bit of error. So this answer is not going to be perfect, but it is going to be a very, very close approximation because I was careful with my drawing and with my measuring. Perimeter here is equal to 15 plus 9 plus 18 plus this last side, even though it's angled differently, it still just has to be measured. And I'm going to say that is, this was 9. So at first glance, there we go. 9.7, which is equal to 15 plus 9 is 24, plus 18 is 34, 42, plus 9, 51.7 inches. We are able to calculate the perimeter of any of the shapes that we have done so far. We don't really need a formula because if we know the lengths of the 4 sides, we can just add them together and that gives us our perimeter. And we have now done the right trapezoid. That was the right trapezoid. Called a right trapezoid because of these right angles that are inside it. But now I'm going to erase the word right because I'm going to erase all of the right trapezoids and I'm going to do the isosceles trapezoid, the second and last type of trapezoid that we are going to use in this lesson. So I need to write the word isosceles, which I can spell isosceles. Some might say that's harder to spell than parallelogram, but not for me. Parallelogram is just one of those words that haunts me and makes me keep on misspelling it years after I learned how to correctly spell it. Okay. Second side of the page. Whew. Okay, I'm going to try to do 3 at a time. Yeah, I'm going to do three isosceles trapezoids. And the strategy for drawing them is a little different. I need bases of 14, 16, and 12 inches. Let's start by drawing those 3 bases. 14, 16, and 12 inches. 14, 16, and 12 inches. Okay, sometimes I put the labels of the lengths of the sides inside the figure, sometimes I put them outside the figure. Go figure. Okay, now what do I want to do? I'm going to mark, I want to have now the isosceles trapezoid. Well, what is it? It's kind of like an isosceles triangle, but since I haven't covered the isosceles triangle yet, I guess that I have to explain what isosceles means. This trapezoid is going to have 2 sides that are equal in length, 2 opposite sides that are equal in length, and it's also going to have 2 pairs of internal angles that are equal. That's kind of interesting. The one base is smaller than the other, like what's happening in my right trapezoids. One of the bases can be smaller than the other, but the smaller base will be centered above the larger base. And that's what I'm going to do next, is I am going to measure this 14, measure the 14 inch, and I don't even have my notes in front of me. Okay, so I wanted the other base in this one to be 8 inches. So, I'm putting a little mark above the 3 and the 11. I'm putting 2 marks 3 inches from the sides, and then, do I have a height chosen? Yes. I'm going to draw heights, and they're not one of the height is not going to be one of the sides. So I'm going to do a dotted line, and the height of this one is going to be 5 inches. 5. So dotted line, 5 inches. Dotted line, 5 inches. I think I'll finish this trapezoid first and not just keep on bouncing back and forth between them, because it's taking a little longer. And then I'm going to connect these. Now these sides, I haven't measured them, but they're equal. The 2 sides that I just drew. And this side is 8 inches long. So that's 8 inches. And the height was 5 inches. Which means we have everything we need to find the area of this trapezoid, because the formula is the same. We need the 2 bases, which we have, and we need the height. If I label this other dotted line, it's also going to be 5 inches. I will mark that these are right angles. Okay. Second one, I'm going to center a base. I'm going to do the same thing. Am I? No, I'm not. I'm going to go 4 inches from each end. And then I'm going to draw the heights, and the heights this time are going to be 6 inches. I can do this. Make those little symbols that show their right angles. And now I will connect the dots and be finished drawing this one. So this top base on this one also happens to be 8 inches. 8 inches. And then the heights were 6 inches. So I'll label just one of them. Okay, that was not so bad. And now the 12-inch one, I want a 5-inch. So I'm actually going to get into the decimals a little bit here. We'll see. Yeah, I'm going 3.5 inches from each side. And how tall is the height on this one? I want a 9-inch height. So you can see how flexible this is. I could say, oh, I want a 9-inch height, and change my mind. You know what? I want a 3-inch height, and I could still do it. I can draw trapezoids with any dimensions I really want. So 9-inch height, this is going to be a tallish looking one. 9-inch height over here as well. So why is he drawing two heights, you might be wondering? Because it makes it easier to draw the rest of the figure. Because I'm able to connect these two vertices, connect these two vertices, and then I just have to draw a line connecting the tops of the two heights, and I have drawn my small base. Okay, and this one was 5 inches, and these heights are 9 inches. I did it. Okay, so now let's get into the area formula. It's the same area formula. Area equals 1/2 B1 plus B2 times H, which is 1/2 14 plus 8 times 5. 1/2 14 plus 8 is 22 times 5. 1/2 of 22 is 11. That's an easy one. 11 times 5 is going to be 55. I have 55 square inches for the area of this isosceles trapezoid. It's an isosceles trapezoid because these two sides, the ones that are not parallel to each other, are the same length. And this base is parallel to this other base. And then there's stuff about the angles as well, but we don't really need to know it to do what we're doing right now. But I can still say this angle here is equal to this one, and then this angle over here is equal to that one. And it will always happen if you truly have an isosceles trapezoid. Now let's do the formula, but fill it in right away. So I'm going to do area equals, and I'm going right into it. It's 1/2 times base 1, which is 16, plus base 2, which is 8, times the height, which is 6. 16 plus 8 is 24. Half of 24 is 12, and 12 times 6 is 72. We have 72 square inches. We have found another area, and this one area equals 1/2. We're getting good at this formula because now we're doing it a sixth time. Good that there are two types of trapezoids because it makes you practice the formula twice as much. Base 1 plus base 2 is 12 plus 5, and then the height is 9. 12 plus 5 is 17. Half of 17 is 8.5. And 8.5 times 9, 72. Is it going to be 76.5 square inches? Doug has learned his lesson. He's getting his calculator. 1/2 times 17 times 9. Yes, 76.5 square inches. Okay, so we've done isosceles trapezoids, and they're really the same as finding the area is the same as with the right trapezoids, but the shapes, you know, it seems quite different. Once you get used to it, it's easy, like anything, but it is quite different. Knowing that there are two types of trapezoid is one of the things that we have to cover in order to be able to understand our quadrilaterals. And I'd like to find perimeters as well. Should I erase? I'm going to erase. It's just too messy if I don't. So I'm going to erase the area answers. And I have some measuring to do again. More chalk, please. Okay, so I have to measure these short sides. Now they have to be equal to each other. So this one, that looks like 6 inches. I'm going to do this one as well, just to say, yeah, that also looks like 6 inches. So that's 6 inches. This is 6 inches. The perimeter is equal to 14 plus 8 plus 6 plus 6, which is 22, 34 inches. I can use that inch symbol. Here, how long is this? That's right about 7 inches. Convenient. And this one, I'm not going to measure it. I know it has to be 7 inches, so I'm going to put 7 inches. So we have a perimeter of 16 plus 7 plus 8 plus 7, which is 23, 30, 38. And this time I'm putting INCHES as my unit. Okay, and now this one. Okay, that's 9. This one has to be longer than 9, and it's almost 10. I'm going to call it 9.8 inches, and that means this one also has to be 9.8 inches. So the perimeter is going to be 12 plus 5 plus 9.8 plus 9.8, which is 12 plus 5 is 17, plus 9 is 26, plus another 9 is 35, plus 0.8 is 35.8, plus another 0.8 is 36.6. 36.6 inches. I use this symbol for inches, I use the word inches, and I use in for inches. None of them are squared, it's not an area, it's a perimeter. It is a distance, it is not an area. Okay, and I really feel like I should double check this, even though I feel like I'm pretty confident. 12 plus 5 plus 9.8 plus 9.8. 36.6, not bad. Okay, let's do some triangles. We're covering a lot in this lesson, really, but largely because I want to make sure to do several examples of each shape. Now triangles, I must say, triangles we really could have a whole lesson just about triangles, because there are a lot of different types of triangle. And I only have 9 minutes left, not even 9 minutes left. Okay, so let's start by just writing the word triangle. And I'll write its area formula, which is base times height over 2. And let's draw some triangles. I'm going to start with an equal. You know what I'm going to do is I'm going to do a couple of triangles, and if I run out of time, well, then I'll stop. So I'm going to start with an equilateral triangle. Nice big one. How about a 20-inch base? Now, how do I make sure it's equilateral? Equilateral means all 3 sides have to be the same length. So I'm going to do that, pulling out my trusty compass. And I'm going to use this 20-inch side to help me set the 2 tips of the compass 20 inches apart. And then I'm just going to draw an arc from this end and an arc from this end. And I am going to connect the point where those 2 arcs meet to each end of this line. Okay, so we have a 20-inch side, but we have 3 20-inch sides. All 3 of these are 20 inches in length. What I don't know is the height. So right now you look at this and you realize he could calculate the perimeter right away. So I will. The perimeter is going to be 20 plus 20 plus 20 equals 60 inches. If I wanted, I could say the perimeter is 3 times the side length because it's an equilateral triangle. So an equilateral triangle, if you want, can have its own cute little perimeter formula. But that doesn't work for all the triangles, it's just good for the equilateral one, so I may as well just add together the 3 side lengths. Okay, so we have the perimeter. I need to know the height, otherwise I cannot find this area. The height looks like 17 inches. Now, if I want to be fussy, I'm going to go to my 20-inch base, and I'm going to mark the midpoint, which is 10. Because the height should go straight up from the midpoint with an equilateral triangle. I didn't necessarily draw it perfectly, but it's been measured. There's a height. The height is, and how long was that again? 17 inches. Again, there could be some drawing error and there could be some measuring error, but it's going to be very close to 17 inches, which means I can find the area. The base times the height over 2. It looks like the rectangle formula and the parallelogram formula, but let's think about the rectangle formula. The base times the height, except we divide by 2. Why? Because if I were to draw a rectangle that this triangle just barely fit inside, the base times the height of that rectangle would be exactly twice as big as the base times the height of the triangle. That's kind of interesting, and that works with all triangles. So let's do it. 20 is the base, and 17 is the height. which is 10 times 17 is 170, so 20 times 17 is 340. But I have to divide by 2, so 170 square inches. We did it. Now let's draw that rectangle just for fun. I'm doing it sort of freehand, but I could do a line straight up from here. I could do a line straight up from here. And then I connect right at the top of this apex vertex of the equilateral triangle. I connect that up. And you can see that this triangle here is the same size as this one. And they're both the same size as this one and this one. So I have 4 triangles that are the same size. 2 of them are, these 2 are inside my triangle. The other 2 are not. They're inside the rectangle though. So if I found the area of this rectangle and divided by 2, it makes sense that it would give me the area of the triangle. The formula makes sense. Let's do one more. 4 minutes. Okay, I'm just going to do a right triangle because those are fairly easy to draw and I don't have time to do more than that. So I'll keep the formula there and I'll erase this example. Did I choose a size for this triangle? Yes, I decided to have a base that's 18 inches long. And I'll be fussy and actually use my protractor and properly draw the height so that it is perpendicular to the base, even though I know my freehand have been pretty good so far. There. And the height I decided to have is 12 inches. So using that little line I drew to help me, and that is a right angle, and this is 18 inches, and this is 12 inches, but it's not a triangle yet, so I have to connect these 2 vertices to make it a triangle. Interesting, this time, I can't do the perimeter yet. I have to measure. But I can do the area, because this side happens to be perpendicular to this side, hence the right angle. Therefore, this side is a height. So I can do 18 times 12 over 2, which is going to be 216 over 2, which is 108 square inches. I have my area. But to get the perimeter, I have to either do some really cool geometry calculations that might tell me the length of this third side, or in this case, for this lesson, I'm going to measure. So, how long is this side? Oh, it's not exactly 22, it's a little shorter, so I'm going to call it 21.7. 21.7 inches, therefore the perimeter is going to be 18 plus 12 plus 21.7, which is 30, 51, 51.7 inches, not squared, and we did it. We don't have time for another triangle. This was fun. The only way it could be more fun is if I allowed students to tell me how long to make everything. And that way they're testing me. Can I still do all of these tricks that I'm showing off if I don't know ahead of time how long the sides are and how big the shapes are? And the answer is yes, yes I can. So if there were students here, we would be doing that. But for this video, we're doing quite well with all these shapes. How many did we do? 4 rectangles, including that yard, and then 3 parallelograms, 3 right trapezoids, 3 isosceles trapezoids, and 2 triangles. So that is 15. We managed to do 15 shapes. I can't say 15 quadrilaterals because the last 2 were not quadrilaterals. They were 3-sided shapes, not 4-sided shapes. So we managed to do 13 quadrilaterals of various sorts and 2 triangles. We did area and perimeter for every single one of those. And I hope we're feeling confident that we know how this works and we're finding it easy and we're finding it fun. I found it fun. She found it fun. I don't know why, but she's standing up and she's wagging her tail. So somehow she knows. something about the way I'm talking at the end of a lesson, maybe because I put down my tools. The dog always knows. So the dog wants to say goodbye. Up, come on. She's a heavy little thing for such a light little thing. So from Mocha, that's her, and Doug, that's me. I want to say thank you very much. It has been fun, and I look forward to seeing you next time.